We're going to take a look at the parathyroid glands, vitamin D3, the thymus, and the adrenal glands in this video. So the parathyroid glands are located right underneath the thyroid gland in the neck. So they're right on the back side. And remember, they got their name because para means next to. So they're just right next to the thyroid gland, right on that back side. And the job of parathyroid hormone is to increase the calcium levels in the blood. And parathyroid hormone is a protein hormone. So here's how parathyroid hormone works. So how it increases the calcium levels is it will go to the bone and stimulate the osteoclast cells, which will start chewing up the bone and release calcium into the blood. And then parathyroid hormone will go to the kidneys, tell the kidneys to reabsorb more calcium from the urine and put that back into the blood. And then parathyroid hormone will also tell the kidney to activate another hormone, vitamin D3. And then vitamin D3 will go to the small intestine and tell you to absorb more calcium from your food, and that will also go into the blood. So all three of those things will increase the calcium in the blood. Vitamin D3 has some long names, but we're just going to call it vitamin D3. But I want you to at least have seen some of these other names. So if you look on a vitamin bottle, if you're taking some vitamins at home, you might see cholecalciferol or calcitriol, and those are just other names for vitamin D3. So they're all the same. So vitamin D3 is a steroid hormone. And so are steroid hormones hydrophilic or hydrophobic? So hopefully you said that it's hydrophobic. And do you remember what steroid hormones are made from? So remember, they're made from cholesterol. Okay, and we do get some vitamin D3 from our diet, and then we're also able to make some in our body, and that involves your skin, liver, and kidneys. And what vitamin D3 is going to do is it's going to go to your intestines and tell you to absorb more calcium from your diet and then put that into your blood. So what's that going to do to your blood calcium levels? So that's going to increase your calcium levels. So vitamin D3 is like parathyroid hormone, and both of those are going to increase your calcium levels. So here's how we make vitamin D3 in our body. So it starts with the sun and hitting our skin, and that will start the process where we take some cholesterol that's in our skin, and then the skin will convert it to a precursor of vitamin D3 that gets sent to the liver, and then the liver will do some processing there, and then it gets sent to the kidney, and then the kidney will just hang on to it until it gets the signal from the parathyroid hormone that says, hey, we need to increase the calcium in the blood. Go ahead and do that last step and activate vitamin D3 and release that. And then the vitamin D3 will go to your intestines and tell you to absorb more calcium from the food that you're eating. So let's just summarize. We've got three hormones that are affecting calcium in the blood. So we've got calcitonin. And remember, that was secreted by the thyroid gland. And remember, that tones down the calcium, that decreases the calcium levels. And then we had parathyroid hormone from the parathyroid glands, and that will increase the calcium. And then we have vitamin D3. And that we get from our diet, and then we can also make that with the sun, skin, liver, and kidneys, and that will also increase calcium. So we've got 1 that will decrease calcium, and then 2 that will increase calcium. So that would be good to know. Okay, our next endocrine gland is the thymus. The thymus is located in your chest, right above your heart, and it's really big as a child. And when you hit puberty, that's when it starts to shrink. And when you get to be elderly, you can't even really find your thymus. It's shrunken up so much. And the thymus is going to secrete a protein hormone called thymosin. And thymosin is going to regulate one of the white blood cells called a T lymphocyte, and is going to help regulate their development and maturation. Okay, and we're going to talk about the T lymphocytes later in the semester when we get to the immune system and what they do. So we think that the thymus shrinking as you age is probably what's contributing to the immune system not working as well in the elderly, because the thymus helps your T lymphocytes develop and mature, and it's really shrunken up and shriveled when you're elderly, and that probably does not help your immune system function very well. Okay, so let's just summarize here and put things down on our little cheat sheet here for studying. So we're going to add our thyroid gland with the calcitonin, and that will decrease the calcium. We've got the parathyroid gland secreting parathyroid hormone that will increase calcium. And then we've got the skin, liver, and kidneys. They produce vitamin D3, which will increase calcium. And then remember, parathyroid hormone actually goes to the kidneys and tells it to activate the vitamin D3. And then the thymus secretes thymosin, which will help with the T lymphocyte development and maturation. Our next endocrine gland are the adrenal glands. The adrenal glands are located right on top of the kidneys. And so you have 2 adrenal glands because you have 2 kidneys. The adrenal glands are a 2-for-1 endocrine gland. So you've got 2 endocrine glands basically in one gland. So if you look inside the adrenal gland, you've got this adrenal cortex on the outside. Cortex means outer. And then you have the adrenal medulla on the inside. And medulla is talking about the middle or the inside. And they secrete very different hormones. The adrenal cortex on the outside of the adrenal gland is going to secrete steroid hormones. And remember, they're hydrophobic. And then the adrenal medulla is going to secrete epinephrine and norepinephrine mostly. And it's actually innervated by the sympathetic nervous system. Okay, let's take a look at the adrenal cortex hormones first. So there are 3 steroid hormones that the adrenal cortex is going to secrete. So the way I remember these is I remember sugar, salt, and sex. Okay, those are the 3 adrenal cortex hormones, what they're going to be regulating. Okay, so we've got glucocorticoids, and if you look at the name glucocorticoids, we have glucose in the name because the glucocorticoids include cortisol, and the cortisol is going to help you deal with stress, and it also regulates metabolism. So it actually is going to increase your blood glucose. And it's also going to do some other things we're going to talk about too. So it does have an effect on your blood glucose levels or sugar. Okay, so that's how it got the name. And then our next adrenal cortex hormone, the mineralocorticoids. This is aldosterone. And it's going to regulate the sodium and potassium levels. And sodium and potassium are salts or minerals. So that's where the name mineralocorticoid came from. Okay, and I do want you to know both of these names, like glucocorticoid and cortisol, mineralocorticoid and aldosterone, because you're going to see both of these used in medicine. And then the last one is the sex hormones, and these are androgens. These are related to testosterone. And these are more important in women than in men, because in men, the testes produce a lot of testosterone, and the little bit that the adrenal cortex makes really isn't going to do much. But in women, because they don't produce a lot of testosterone anyway, this is where a lot of their testosterone comes from. And so in women, the testosterone being produced by the adrenal cortex is going to help with the sex drive in women. Okay, so these are the adrenal cortex hormones. They're all steroid hormones. They're all hydrophobic, and they're all made from cholesterol. Okay. The adrenal medulla hormones. Okay, the adrenal medulla is innervated by the sympathetic nervous system. And when it stimulates the adrenal medulla, it will release mostly epinephrine, or also called adrenaline, a little bit of norepinephrine or noradrenaline, and a tiny amount of dopamine. Okay, and all of these are amine hormones. They're all hydrophilic. And all of these are catecholamines, if you remember. And that's just because of their structure. Okay, they have that catechol ring. And what epinephrine, norepinephrine, and dopamine are going to do is they're going to help with your fight or flight response. So sympathetic nervous system gets stimulated when, maybe you're hiking down the trail and a bear jumps out at you, and you've either got to run away or fight the bear. Okay, and those hormones are going to help you do that. Okay, and we'll talk about what the body does with fight or flight later on in another chapter. Okay, let's just take a look at one of the adrenal cortex hormones. Let's look at the glucocorticoid cortisol. So what's going to stimulate you to release cortisol? There's two things. One of them obviously is stress, because cortisol is going to help you deal with stress. And the other one is circadian rhythms. So here's this circadian rhythm, and you can see that cortisol release is going to be highest in the morning and lowest at night. And you might notice that, like, during the morning you usually have more energy, and at night, you're not as much energy. And a lot of that's due to cortisol. Okay, because cortisol is going to mobilize your energy stores and make those available for your cells, and that'll help you, have more energy available to do things, which is kind of interesting. Okay, so here's the control of how cortisol is released. So we start again with our hypothalamus, and hypothalamus is going to release the hormone CRH, which stands for corticotropin releasing hormone. And then CRH will go to the anterior pituitary through the portal system, and then that will stimulate the anterior pituitary to release ACTH, or adrenocorticotropic hormone. And then ACTH will travel through the blood to the adrenal cortex and stimulate it to release cortisol. Okay, and then cortisol is going to have some effects on the body, will help you deal with stress, and then also will have some effects on metabolism, which we're going to look at next. And then remember that everything is controlled by negative feedback, because we don't want the cortisol levels to get too high and get out of whack. So cortisol will feed back onto the anterior pituitary and hypothalamus. So if cortisol levels are getting too high, it'll say, hey, anterior pituitary, hypothalamus, we don't need any more CRH or ACTH because our cortisol levels are too high. Let's wait till those go down before you release any more. Okay. All right, so what does cortisol do? So it has some effects on your metabolism. So cortisol is a catabolic hormone. So I definitely would remember that. Okay, so it's going to mobilize your energy stores. Okay, and this is going to help you deal with stress. Okay, so it's going to increase your glucose in your blood, and it does that by going to your liver and telling your liver, hey, let's do some gluconeogenesis. Let's make some new glucose from things that aren't carbohydrates. And it tells some of the other cells in the body, like your fat cells and muscle cells, hey, don't take up any glucose right now. Let's leave that for some of the other cells. So it does increase your glucose. It also increases the amount of fatty acids in the blood. And how it does that is it increases lipolysis. So it goes over to your adipose and tells those adipose cells to start breaking down your triglyceride stores and release the fatty acids into your blood so cells can use that as an energy source. And then it also increases the amino acids in the blood. And it does that by telling your cells, hey, start breaking down some of your proteins. And remember, that's called proteolysis. Okay. So it definitely has some effects on your metabolism. So it is catabolic. And then it also is anti-inflammatory. So if you think about if you have like a rash or something and you go to the drugstore and you get some cortisone cream, okay, that takes away the redness and irritation, doesn't it? Okay, it takes away that inflammation. And also, a lot of cortisol will suppress your immune system. So if you're under a high level of stress, or maybe you're taking a medication with cortisol in it, so maybe something like prednisone, high enough doses can actually suppress your immune system. So you may have noticed that, maybe after final exams, you always get a cold or something. I don't know, that was always happened to me when I was in school. So just your immune system gets suppressed because of all the stress. So that can happen as well. Okay, let's take a look at some problems with cortisol secretion. So we've got two of them. So Cushing's disease. This is also called hyperadrenocorticism. So hyper meaning excessive. So you're secreting too much cortisol. So maybe you've got a tumor in the anterior pituitary or the adrenal cortex, or maybe you're taking a lot of cortisol. Maybe you're taking a lot of prednisone or something. So you have way too much cortisol, and that's going to cause a lot of problems in the body because it changes your metabolism, right? It's catabolic, it increases your blood glucose, you get hyperglycemia, which is increased blood glucose. You start breaking down proteins in the body, you break down fats in the body, and so this causes all kinds of issues in the body. And then Addison's disease is the opposite of Cushing's. So this is hypoadrenocorticism. So hypo meaning too little. So usually this is an autoimmune disease where the immune system attacks the adrenal cortex and starts destroying it. So then you can't release enough cortisol and also aldosterone. And so without that cortisol there, you actually do need cortisol normally. If you don't have that cortisol there, you get hypoglycemic. So not enough blood glucose, and so that makes you really weak. And then you don't respond to stress very well because you don't have the cortisol. And then the aldosterone being low, aldosterone actually will help monitor the sodium and potassium levels, keep those in the normal range, and now you're having a problem where that's not happening. So aldosterone not being secreted will cause the sodium levels to become low and then the potassium levels to become high, because normally what aldosterone does is it goes to the kidneys and tells your kidneys to save sodium from the urine, and then water will follow that as well. And then it also tells you to secrete potassium into the urine. And then this will increase your blood pressure from the water going into the blood. And then it also makes sure you maintain your sodium and potassium homeostasis. So if you don't have enough aldosterone and you're not saving the sodium like you should and putting it back in the blood, then your sodium gets too low. And if you're not secreting the potassium from the blood and peeing it out in the urine, then the potassium builds up in the blood and it gets too high. And so the sodium and potassium not being in the normal range can actually cause some arrhythmias in your heart, and also can cause some problems with muscle weakness too. So that can be pretty dangerous. And then also you're not saving enough water from the urine. You can get dehydrated, you can get low blood pressure, and so this can be pretty serious. Okay. All right, so let's look at somebody with Cushing's disease. So remember, this is hyperadrenocorticism. So you're secreting too much cortisol, and so you're just mobilizing your energy stores, and this is going to cause all kinds of problems. So breaking down the fat stores, well, you can't use it all because you're not under stress. So your body's like, well, this isn't all getting used, so let's put it somewhere. So you end up depositing the fat stores in the face. And so you get what's called a moon face, because the face gets very round because of the fat deposits. And then the fat also gets deposited on the back between the shoulder blades, and they call that a buffalo hump. There's also some fat deposited in the abdomen. And then also because of the protein breakdown, the abdominal muscles become very weak, and the abdomen will kind of, pooch out. And so they get this real pot belly look to them. And because the proteins are being broken down in the muscles get weak. The proteins being broken down in the blood vessels will cause bleeding under the skin. If you get a wound, because you're not able to make proteins very well, they're being broken down, the wounds won't heal very well. The skin will get kind of wrinkled and thin because proteins are being broken down. And then the blood glucose is high, so the person could get diabetes. They're usually drinking a lot, urinating a lot, because there's a lot of blood glucose spilling out in the urine, and that will draw the water with it. And so there's just all kinds of problems that happens with Cushing's disease. Okay, so let's just take a look at what happens if we look at the blood work with someone with Cushing's disease or Addison's disease. So this will be good to know for the test. So let's just draw this out. So remember that it starts with the hypothalamus releasing CRH into our portal system. And then the CRH will go down to the anterior pituitary, jump off, and tell the anterior pituitary to release the hormone ACTH. Okay, and then ACTH will travel through the blood to the adrenal cortex and then tell the adrenal cortex to release cortisol. And then remember, cortisol will have a negative feedback effect on the anterior pituitary and then also on the hypothalamus. Okay. All right, so let's say that our patient has Cushing's disease, and let's say that our cause is we've got a tumor in the adrenal cortex, and it's secreting lots of cortisol. So if we check our blood work, we'd have lots and lots of cortisol. And then what do you think the CRH and ACTH levels would be if the cortisol levels are really high? So think about our negative feedback effects on the anterior pituitary and the CRH from those high levels of cortisol. So hopefully you said that the CRH would be low and also the ACTH would be low. Okay, because of the negative feedback effect from the high cortisol, will feedback and CRH and ACTH levels will be low. Okay, what if the cause of Cushing's disease is that we've got a tumor in the anterior pituitary? And that's releasing lots and lots of ACTH. And so all of that ACTH is going to the adrenal cortex and telling it to release lots and lots of cortisol. So what would be our CRH level? So hopefully you said because of the negative feedback effect of all that high cortisol, we'd have a low CRH level. Okay. So by looking at the blood work, we can figure out where's the tumor. And then we can figure out, well, where do we need to go and do surgery, okay, to remove the tumor. Okay, now what if our patient had Addison's disease? What do we see there? Okay, remember Addison's disease, we've got the opposite problem, right, of Cushing's. So our cortisol levels are really low because the immune system is destroying our adrenal cortex, and also our aldosterone levels will be low too. And then what would our CRH and ACTH levels be? So cortisol being really low, our hypothalamus and anterior pituitary would be screaming at the adrenal cortex and saying, hey, you're not doing your job. You need to be releasing cortisol. And so the CRH and ACTH levels would be high. Oops. Okay, but unfortunately the adrenal cortex says, well, I can't do any more because I'm being destroyed. Okay, but that's what we would see if the patient had Addison's disease. Okay. All right, so I'd be able to look at something like this on the test and be able to predict what the blood work results would be. You know, if I gave you that, oh, you know, the cause of Cushing's disease is like an adrenal cortex tumor, you know, what would you expect the blood work to be? Or maybe I gave you the blood work results, you know, where would the tumor be? Okay, so be kind of thinking about that and, know these pathways. Okay, and then this is just from your book, what we just drew out. Okay, and then just summarizing, we finally have finished our picture here, looking at all of our anterior pituitary hormones. So we've just added in hypothalamus with CRH, going to the anterior pituitary. Anterior pituitary releases ACTH, that goes to the adrenal cortex. And oops, I forgot to put cortisol. There we go, cortisol. And then cortisol will help your body deal with stress, and then change your metabolism to help you deal with stress. So it's a catabolic hormone. It'll mobilize the energy stores. It'll tell your body, break down proteins, break down your fats, increase your blood glucose. And then the two problems we can see with cortisol would be Cushing's disease or hyperadrenocorticism, and then Addison's disease or hypoadrenocorticism. Okay, and then also finishing up this one, we've got the adrenal cortex I've added here. Cortisol was on our other slide, but I've put on here aldosterone. Goes to the kidneys, tells the kidneys to save sodium, and then water will follow. And also excrete the potassium into the urine. And then by saving water into the blood, that'll increase blood pressure, and then also to help regulate the sodium and potassium homeostasis. And then adrenal cortex also secretes androgens or testosterone, which is involved in the sex drive in women. And then the adrenal medulla secretes epinephrine, norepinephrine, and dopamine, which are involved in fight or flight.